Hello everyone, this is Dave and welcome back to my channel. In today's video, we'll be taking a look at the product rule from calculus. In particular, we'll look at a way to derive the product rule using the FOIL method from algebra. Now let's suppose we have a rectangle as shown on the screen. The length of one of the sides of the rectangle is a plus b and the other has the side length c plus d. In this case, we can say that the total area is the sum of each of the smaller rectangles. That is to say, the blue rectangle plus the yellow rectangle plus the green rectangle plus the very small red rectangle. This is AC plus BC plus AD plus BD. If we sum all of these up, the total area of the rectangle is AC plus AD plus BC plus BD. Now, we can also do this algebraically. If we multiply the binomials a plus b and c plus d, we can use a technique called the FOIL method. The FOIL method is a method that is usually introduced in a middle school algebra class. And FOIL stands for first, outer, inner, last, and this represents the order in which the multiplication is carried out. By this method, the first product is AC. The second product is the product of the two outer terms, so it's AD. The third is the inner product, which is BC. And the last is the last two terms, which is BD. To get the total area, we add all of these terms up and we get the same thing for both methods. This is the total area, which is AC plus AD plus BC plus BD. Now let's take this same method and apply it in the context of calculus. As you know, in calculus we deal with functions rather than with numbers. So rather than letting the side length of the blue square be a number, I'm going to represent it by a function f of x. If I increase this length, the length of the top will increase by df. By the same rule, the height of the blue rectangle can be g of x, and it can be increased by an amount of dg. We follow this, then the area of the blue rectangle is f of x times g of x. The area of the yellow rectangle is g of x times df. The area of the green rectangle is f of x times dg. And the area of the red rectangle is df times dg. I can now use the exact same FOIL method that I used before, and if I do this, the product of the first terms will be f of x times g of x. The product of the outer terms will be f of x times dg. The product of the two inner terms will be g of x times df. And the product of the last two terms is df times dg. In calculus, we're mainly concerned with the change. So therefore, I only need to consider the new area that's been added. If I do this, I have dA, the change in area, is equal to g of x times df plus f of x times dg plus df times dg. If I divide through by dx, I can get dA over dx is equal to g of x times df over dx plus f of x times dg over dx plus df times dg over dx. We are now getting very close to what we know to be the product rule in calculus. Keep in mind that A is really the area of the rectangle, which is f of x times g of x. Therefore, dA over dx is really the derivative of the product of f of x times g of x. If we write this in the prime notation, we get f of x times g of x quantity prime is equal to g of x times f of x prime plus f of x times g prime of x plus an extra term. This extra term was originally df times dg over dx. However, we can multiply it by dx over dx and get df over dx times dx over dx times dg. We can then arrange this slightly so that the last term is df over dx times dg over dx times dx. However, it turns out that this term is so small that it doesn't really matter because we're multiplying by the infinitesimal. So therefore, this term will go to 0, and it will eventually just drop out. Therefore, we have that the derivative of the product of two functions is equal to f prime times g plus g prime times f. This is the end of the video. If you liked this and found it useful, please like and subscribe to my channel. Thank you very much, and I'll see you in the next video.